Problem number 2. In parallelogram ABCD. Okay. They tell us a lot with that statement, right? This is a parallelogram, therefore opposite sides are parallel and congruent. And same with these sides, parallel and congruent. I also know a lot of stuff about the diagonals too. Namely that they bisect each other. So these will be congruent, and then these here, 1, 2, 3, 4, 1, 2, 3, 4, they'll be congruent. That's all just from that fact that I got a parallelogram there. And then it says which statement must be true, and I'll just kind of go through them. Let's see. AC is congruent to AB, or sorry, DB. AC is congruent to DB. No, my diagonals in a parallelogram are not necessarily congruent, so it's clearly not that. Angle ABD, ABD. This angle here is congruent to angle CBD, CB. No, the angles aren't necessarily, the diagonals aren't necessarily bisectors. They're not going to be congruent. I mean, take a look over here. See how these are grossly different? So the same logic applies over here. Those are not necessarily congruent. Okay, and it says which must be true. Let's skip down to 4. Triangle DCE. DCE. That triangle is congruent to BCE. BCE. And you can tell they're not the same shape, same size, I mean, as well. By process of elimination, it seems that our answer is number 3, and we'll just confirm that. Triangle AED. AED is congruent to CEB. CEB. And I mean, you can, I hate to say it, go off looks, but also notice these triangles are congruent via the side postulate, because I've got congruent sides from parallelogram. I've got another pair of congruent sides from the diagonals of a parallelogram are congruent, and then the same thing here. These sides are also congruent. So this is the side postulate.